Hi everyone. Today we're going to study factoring. Specifically, this is factor the greatest common factor, GCF, from a polynomial. First, let us define greatest common factor. The greatest common factor, or GCF, of two or more expressions is the largest expression that is a factor of all the expressions. How to find the greatest common factor? We're going to follow some steps. Step 1. Factor each coefficient into primes. Write all variables with exponents in expanded form. Step 2. List all factors matching common factors in a column. In each column, encircle the common factors. Step 3. Bring down the common factors that all expressions share. Step 4. Multiply the factors. Let's have an example. Find the GCF, or greatest common factor, of the three terms. 21x cubed, the second is 9x squared, the third term is 15x. In step 1, let us factor each coefficient into primes. We write all variables with exponents in expanded form. So the 21x cubed is now factored out into 3 times 7. That is the prime factors of 21. And for the x cubed, we are going to write the x here 3 times. For the 9x squared, this is equal to 3 times 3 times x times x. For the 15x, this is equal to 3 times 5 times x. Step 2. List all factors matching common factors in a column. So the factors are now written like this. For the common factor 3, it is written in one column. There is also another common factor of x written in another column. It says in each column, encircle the common factors. So we encircle the 3, the common factor 3, and also the common factor x. Step 3. Bring down the common factors that all expressions share. So the 3 is brought down here, also the x. And then the step 4, we will multiply the factors. So the greatest common factor equals 3x. Let us go to factoring. What is factoring, by the way? Splitting a product into factors is called factoring. Example, find the factors of 6. It is showing here that the factors of 6 are 2 and 3. We know that there are other factors like 6 times 1 for this number 6. However, for this topic of factoring, we will only consider prime factors. Let us note that prime numbers are integers greater than 1 whose only factors are 1 and itself. Examples are 2, 3, 5, 7, 11, 13, and so on. Let us discuss now factoring the greatest common factor from a polynomial. We are going to follow some steps. The step 1 says, find the GCF, or the greatest common factor, of all the terms of the polynomial. Step 2, rewrite each term as a product using the GCF. Step 3, use the reverse distributive property to factor the expression. Step 4, check by multiplying the factors. Let's have example 1. Factor the trinomial 6x cubed minus 9x squared plus 12x. Our step 1 says, find the GCF of all the terms of the polynomial. In here, the GCF is 3x. Looking at the numbers 6, 9, and 12, the greatest common factor of these three numbers is 3. For the variables x cubed, x squared, and the x, the greatest common factor is x. So the GCF of this trinomial is 3x. Step 2, let us rewrite each term as a product using the GCF. It means we're going to split each term. Look at the first term. The 6x cubed is split into two factors in such a way that one factor should be the GCF. So the 6x cubed is now factored out into 3x and 2x squared. The second term, negative 9x squared, is now factored out into negative 3x, the GCF, times the 3x. For the 12x, the factors are the GCF 3x and the number 4. For step 3, use the reverse distributive property to factor the expression. It means to say we're going to remove first the GCF from the three terms. So see, the GCF is now outside, and then on the second factor, we're going to collect all terms that will remain for each term here after removing the GCF. Look at the first term here. After removing the GCF, the 2x squared remains, so it is written here 2x squared. For the second term, after removing the GCF, only the 3x is coming, so this is minus 3x. And then plus, for the third term, after removing the GCF, only the number 4 remains, so we will copy here 4. Step 4, let us check our answer by multiplying the factors. We should go back to the original problem after the multiplication. So the 3x multiplied by the 2x squared, I will get that 6x cubed. And then the 3x multiplied to negative 3x, the answer is negative 9x squared. And then 3x times 4 is positive 12x. So we are sure that this is correct, and this is our final answer. Let's have the second example. In here, there are two big groups. It is a difference of binomial. Look at this first group here. It is a product of 3y times the quantity y plus 7, and then minus. The second group is 4 times the quantity y plus 7. Let us go to our step 1. Find the GCF of all the terms of the polynomial. So our GCF is this y plus 7. That is the common in the first group and in the second group. So I wrote here the GCF, that same y plus 7. Step 2. Rewrite each term as a product using the GCF. In this problem, it is already in the form of a product in such a way that one of the factor is the GCF. So we just copy that same problem. In step 3, use the reverse distributive property to factor the expression. So we're going to remove first the GCF. So removing the GCF here, we expect two terms in the second factor. In the first blank here, I'm going to write the remaining term after removing the GCF. So looking at this first group, I can see here that 3y will remain after I remove the GCF. So I will write the 3y. And then plus. For the second blank, I'm going to write here the remaining term after removing the GCF. So that is the negative 4. So negative 4 will come down here. So this is plus and minus. I will simplify this into negative 4. And step 4, let us check by multiplying the factors. So we want to multiply these factors and hoping that we will get back the original problem. So the first group is this 3y times the GCF. So this is our 3y. If I multiply by the first group or the GCF, I will get the first group here. And then this negative 4 multiplied by the GCF here, I will get the second group, the negative 4 times the quantity y plus 7. So now I am sure that this answer or these factors are correct, and this is our final answer. Thank you for watching. See you again next time.